This lesson is about solving both exponential and logarithmic equations. And these are kind of the things to think about. We're going to start with the exponential equations. You're going to isolate the exponential expression when possible. You're going to rewrite the bases on both sides to be the same if possible. So you're looking, if they're the same, then you're going to try to rewrite them. If not, you're going to rewrite the equation using logarithms. Since we're in exponential form, you don't have to restrict the x-axis because remember, exponents can be negative, so we don't have to worry about that. And exponential equations can be used, can be solved using both the common logs or natural logs, if you want. Okay, this first one, I'm looking at the bases of the exponents, and the one on the right, the square root of 3, I can write as a base of 3. So I'm going to do that first and get 3 to the x minus 1. Remember, square root makes a fractional exponent, so x plus 2. And now that I'm in the same base, I can just drop those bases and solve the exponents. So I'm going to subtract 1/2 x from both sides and add 1 to both sides. So I get 1/2 x equals 2, multiplied by the reciprocal, x equals 4. Okay, this next one, I have an exponent. It's only on one side, so I'm going to isolate. So I'm going to start by getting rid of that minus 6 by adding 6 to both sides. 7 raised up to the 1/3 x minus 2 equals 16. Now I'm going to rewrite this in log form. So remember, the base stays the same. The 16 comes to this side, and now I write that equation. So I'm going to get this calculator ready, so that way if you're going to plug it in your calculator, we make sure we do it right. So this, I'm going to add that 7 first. So log base 7. I'm going to put that argument of 16 into parentheses because that will never change. I'm going to add the 7. Now I'm going to multiply both sides by 3, but you need to make sure you understand that this entire expression is in parentheses. Now I type that into my calculator. Make sure you put, well, I put a blue bracket, but make sure you put it in parentheses in your calculator. So I'm going to get x to be approximately 10.2, and there's my solution there. Okay, so now this next one, the exponent is isolated, so I'm just going to go straight to log. So log base 5 of 6 equals x minus 1. Then I'm going to bring that, to get x by itself, I'm going to add 1. Now I'm going to plug this into my calculator. And I get 2, that's approximately 2.1133. Okay, now I've got exponential, and it's already isolated, so I'm going to go straight to log. Remember, a base of e is the natural log. The argument equals 2x. Now I'm going to divide by the 2, so ln 5 divided by 2. So x is approximately 0.8047. Okay, this next one, I've got some isolation to do. I've got to get this, what's in parentheses, by itself. So I'm going to add that 8 first, and that's going to get 14. Now I'm going to divide by that 2, and now my exponent is isolated. Now I'll go to log, so log base 5 of 7 equals x minus 1. So then I am going to add that 1. Remember, the 7 is the argument. It doesn't change. So now I put this in my calculator, and it's 1.1045. Okay, this next one is still an exponent. I need to isolate that e to the x raised up to the x divided by 3. So I'm going to add that 2. Get 2 over x3 equals 6. Divide by that 2 and get 3. Since that's a base e, I'm going to go to natural log. And then I'm going to multiply both sides by 3. So 3 ln 3 equals x. So x is approximately 3.2958. Okay, this one here, I can see that I can write it into the same. If you don't see that you can write it in the same base, then you can always change this into logarithms. But I'm going to do this because it saves me from having to pick up a calculator. So 3 over x plus 2 equals 3 to the negative 3. So now I drop my bases and do x plus 2 equals negative 3. Subtract the 2 and it's negative 5. You could have written log base 3 of 1 over 27 equals x plus 2. And then log base 3, 1 over 27 minus 2 equals x. Put that in your calculator and you're still going to get minus 5. Okay, this next one, I can write these in the same base. When I have exponents on both sides, then you have to do it this way. So I have 3 to the third is x minus 3 equals 3 to the fourth, not times 2x plus 1. Drop my bases, distribute 3x minus 9 equals 8x plus 4. I'm going to subtract my 3x, subtract my 4. So negative 13 is equal to 5x. Divide by 5, and I get negative 13 fifths. Okay, now this one is tricky because this is addition. So we're going to do something different. Calculus people, these are for you. So I'm going to first write 2 to the 2x, same base, 2 to the x minus 20. I still can't add those bases together because there's no rule for that. So we're going to do something that's called subbing. In place of, we're going to rewrite the bases of 2. Well, we're going to make a equal 2 to the x. So now I'm going to rewrite of a squared, because 2 to the x, I'm left with a 2 up there, so it's squared, plus a, because that's 2x, 2 to the x, minus 20 equals 0. This is factorable of a plus 5, a minus 4. So a equals negative 5, a equals negative 4. Now I'm going to go 2 to the x is equal to negative 5, and 2 to the x equals 4. So I'm subbing back in place of a, the 2 to the x. Well, this one can't be done because I can't take 2 and make it negative. But 2 to the x, if you don't know, you could obviously write log base 2 of 4 equals x, put it in your calculator. But I also know 2 to the second power equals 4, so x is equal to 2. Okay, now we're going to move on to logarithmic equations. We're going to condense the logarithmic expressions, equations when possible. That means one side may condense. We're going to isolate the logarithmic component just like we did the exponent. If we have logs on both sides that have the same base, we can set the arguments equal to each other, just like if we had exponents with the same base, we could drop the bases and set the exponents equal to each other. If necessary, we're going to rewrite the logarithmic equations into exponential form to solve. And we're going to make sure that we check for extraneous solutions. So these have extraneous solutions because the argument can't be negative. okay? If the argument's negative, then that solution's considered extraneous or a false positive. Okay, this first one, I always go put my eyes on where the equal sign is, and it's right there. And so I only have log on one side. So that means that I can't drop the logs. It means that I'm going to see if I can isolate. The log is already isolated. Notice the parentheses around the argument, so that piece stays together. So I'm going to immediately go into exponent form. So we're going to rewrite from log to exponent. So remember, that is done. Oh, my pen just turned off. Of 2 to the third power equals that 2x minus 4. I'm going to power that 2 to 8. And now I have a simple linear equation to solve. Add 4. And then divide by 2. So x is equal to 6. Okay, the next one, the log is isolated. This is a little bit different because of where the x is. So I'm going to rewrite it into exponent form and think, okay, x to the negative 2 power equals 1 over 81. Well, I think about, okay, so what squares to make it 81? And to the negative 2, of course, brings it to the denominator. So that would be 9. Okay, so I need to isolate the log by itself. And the piece that I want to isolate is the log and the argument. Those are the things I want to get by itself. So we're going to do the same order that we would solve any other equation. We're going to get rid of the addition problem first. So 2ln x minus 1 equals 10. Now we're going to divide by 2 and get ln x minus 1 equals 5. Now I'm isolated. I'm in log form. My argument has the x, so I'm going to convert it to an exponent. So remember, the base of a natural log is e, so e to the 5th equals x minus 1. Now I'm going to do e to the 5th plus 1 equals x. Now I'm going to plug that into my calculator. And so x is approximately 149.4132, because that's like almost 3 to the 5th power. Okay, so the next one, I look at my equal sign. I've got logs on both sides. So I'm going to condense the right side first. So log base 3 of x minus 4 equals, remember that the 2 in front makes that an exponent. So 4 squared minus means division over 2. Oops, I forgot the log in there. Sorry about that, guys. I didn't write the log, and so that's my mistake. So log base 3 of 4 squared divided by 2. Now I'm condensed. I can take log of both sides and get x minus 4 equals 4 squared is 16. 16 divided by 2 is 8. So I'm going to add that 4, and there is my solution. Okay, I've got logs on both sides, so I'm going to start with seeing what gets condensed. The left-hand side has a subtraction, so I'm going to write log base 3 once. 10 divided by 6 equals log base 3 of 5x. I take the log of both sides, so that is 5/3 equals 5x. Since I have a fraction, I'm going to multiply by the reciprocal, and that gets me x alone, and it's 1/3. And there is that solution. So here I have log on one side, so that means I'm going to condense and rewrite it into exponent. So the plus means multiplication, so x plus 2 times x minus 1 equals 1. Well, now I've got to FOIL this, and so that's x squared minus x plus 2x minus 2. So log x squared plus x minus 2 equals 1. So now that I have it condensed, I need to rewrite it into exponent form. Remember, a log with no number is an understood 10. So 10 to the first power equals x squared plus x minus 2. I'm going to subtract that 10, get x squared plus x minus 12. This is factorable. Factors of 12 that give me positive 1 are positive 4 and negative 3. X equals negative 4, x equals positive 3. I come back to my original, and I think of this is where I'm checking for extraneous solutions. I'm going to plug those values of x up there. And so if I put a negative 4, if I put a negative 4 in place of that x, negative 4 plus 2 is negative 2. That is extraneous. Doesn't matter what it does to the other one. It doesn't work there. Now I plug in the 3. 3 plus 2 is 5. 3 minus 1 is 2. So it has one solution.